Hello class, welcome to week 4 of Python 1. This week we have a really cool chapter, a lot of fun stuff that we can do this week that we're going to be learning out of chapter 3 related to mathematical functions, strings, and objects. So let's get started. And once again, the stuff that I lecture on in this lecture covers the high points of the chapter. Again, the most important thing that you should be doing is reading through the chapter also and doing the problems along with what you are reading, because practice helps you to become a better programmer. And so you should view the lecture as a bonus material just to help reinforce what you've already learned and to answer any questions that you might have. So your book talks a little bit about mathematical functions in Python, and there are two types of mathematical functions when we think of Python. One is the type of function that do not require an import, and those that do require an import. And there are several types of functions in Python that don't require an import, and we'll just cover, your book covers a lot of them, but these are kind of the high points. And for example, if you're wanting to learn the absolute value of something, you can use the ABS for absolute value to determine that, and whatever is inside the parentheses inside ABS is the value of the item that you want to find the absolute value of. And so in this particular line of code, we are saying print to the console the absolute value of -3 is, and then we do this little function of absolute value of -3, and then it will return that absolute value. Now we can also print, find the maximum or the minimum value of a numbered list. And so in this particular function here, we say return the maximum number in this particular list, 2, 3, 4, or 6. And so what you might do is you could certainly give a numbered list, but you could also prompt the end user to type in 4 numbers, and it would return, based on that entry, the maximum number within that list. And then you have the POW function, which raises the first number to a power. So in this, we're saying raise 2 to the 3rd power, which we know is 8. And then we have the round function, which rounds us to the nearest integer. So I'm going to run this function, and let's see what happens here. And so we get our 4 answers here. So the first one, we know that the absolute value of -3 is 3, which is correct. Then we want to return the maximum number in the list. 6 is correct. 2 to the 3rd power is 8. And then 3.51 to the nearest integer is 4. Now let's run them one more time. And what if we say 3.4? And let's see what happens here. And when we run it, it rounds it. We have the same 3 first numbers, but it rounds that 3.4 down to the lowest integer. So that's what it's doing for that in that particular case. Now we also have several math functions. A lot of them are trigonometric or geometric functions that do require an import. And so whenever, just like we do with Turtle, we can import the math module. And what this does is it pulls in different mathematical functions that are not normally accessible, and you do have to import them in order to be able to access them. And your book gives a lot of different numbers that you can, a lot of different mathematical functions that you can use. Specifically, we've pulled out the square root function, and so we know that first, whenever we're using these functions, we start by importing math, and then to use these functions, it's always math dot and then whatever the name of the function is. So math dot square root of the value that's inside parentheses, and that is 4. And so we know that the answer here should be 2, and when we run it, yes, that's correct. So 2 is what comes out because the square root of 4 is 2. So you can use all of these mathematical functions to do some advanced trigonometric or geometric functions. Next, your book talks a little bit about strings, and we know that strings are nothing more than a sequence of characters, and you know, any types of numbers or letters can be a string. And so the most important thing to be able to denote them is that you want to enclose them in single or double quotation marks. In different programming languages, the single or the double quotation marks matter, but in Python you can use either single or double. So say for example we define a variable called letter, and we say that the value of the letter variable is the letter A. And then we want to print out, in this next line, we want to print out the value of the letter variable is, and then comma letter. And so here it will print out the variable value for letter. And then we create, and then after that we create another string variable called numchar, and we notice that it is the number 4 that is in single quotation marks. And it's interesting here because it's in quotation marks, it'll get read as a string as opposed to an integer. And so because of that, if we were to try, it'll print out here, but if we were to try to print numchar, which is a string, and add it to the number 4, we would get an error, a type conversion error, because numchar is of type string. Instead, what you would want to do is you would want to use the integer function, which converts a string to an integer, and using numchar as an argument, and then it should print out 8 as that particular value. So let's just go this. Let's do this just to make it a little bit more accessible. So that way it's a little bit easier to read. So let's save it and let's run it. All right, so here we see our 3 lines of code ran. So the value of the letter variable is A, then the value of numchar is 4, and then the sum of numchar when cast as an integer and 4 is 8. Now just to prove my point, I'm going to try to run this numchar plus 4 without casting as an integer, and let's see what happens. Okay, so again, the first 2 lines of code run properly, but then whenever we try to add numchar, which is a string, to an integer, then we get this error message that says that that we can only concatenate a string, not type of integer to a string. So we can't do addition with a string and an integer. Okay, easy enough. Another thing that your book talks about is the fact that Python has several types of escape sequences which allow us to do different types of operations with text. So there might be some times whenever you want to use print to the console quotation marks, and if you try to do that without without any other sort of things, for example, in this line right here, we try to print out, he said, my dog is a beagle, and we try to put that in quotation marks, we're going to get a syntax error. So just for fun, we'll run it knowing that we're going to get an error message. And yes, we did get an invalid syntax error. So what we have to do is instead we have to use what's called an escape sequence. And to do that, we use the backslash, single quotation mark, or the single quotation mark with the backslash, in order to surround a string with quotation marks. So say for example, when I print to the console, he said my dog is a beagle. The correct way to do that is not this, but instead it's this: print quotation marks he said, and then we have the forward or backslash with the quotation mark, and my dog is a beagle with a backslash quotation mark and a and then the ending quotation mark. So let's see what happens when we run this. Okay, so you can see that it prints out correctly just as we want, because this escape sequences help to capture the quotation marks that we're wanting to have. We can also prevent line feeds after printing to the console. So say we have multiple lines that we want to print, then normally if we were to do that, we would get these on two separate lines. But what if we wanted AAA and BBB on the same line? Well, you can use the end keyword to keep them on the same line, and so we can use this end equals and then some value, and that will keep this AAA and BBB on the same line. It'll just separate them by the value that is between the end keyword. And so you notice when we ran it that we have AAA and then space, and that space is equivalent to the value that's inside end, and then BBB. Now we can also use, just like we can cast a string to an integer, we can convert a number into a string. And so we use that using the string function. So here we declare a variable called s, and we say it's equal to the string value of 3.4, and then we print s out to the console. And when that runs, then it prints out a string value of 3.4. And obviously, since it's a string, we couldn't ever do any type of math with it without converting it back to an integer. And then finally, we can use what's called concatenation, which is combining multiple strings using the plus sign in order to leave them all on the same line. Just notice that it's really important that you insert a space at the end of the first string in order to avoid the strings running together. So you'll notice that I declare a string variable called now is the time, and then notice that there is a space after time, because otherwise N and O would be all one word. And then the O value is for me to sleep. So you notice that the spacing's correct here, but what happens if I were over here to delete this extra space here and try to run it? Then you'll notice that time and for get concatenated together. So this is the concept called concatenation, and you will use it a lot in Python whenever you are trying to format output to the console. All right, next let's talk about the input function. The input function is really, really powerful because it allows us to read a string from the console. And so let me talk a little bit about the input function. So in this program, we declare a variable called s1, and we say it's equal to the value, the input value, and so what we're printing out to the console is the value. Enter your first name, and we prompt the user to enter their middle name and then their last name. So each of these are enclosed by the input function. For S1, S2, and S3, and then what we want to do is then we print out to the console the value of S1 that's been entered, plus, and then we just add a little space, so we're concatenating in a little space, and then the value of S2, concatenated with another space, and then S3. And let's see what happens when we run this program. All right, so now here we are, and so it's prompting us to enter our first name. So my first name is Brian, and my middle initial is L, and then my last name is McMurtry. When I press enter, then it runs this last line, print S1 plus S2 plus S3 concatenated together, and it prints my full name out to the console after having stored each of these into variables called S1, S2, and S3. Okay? So this is the idea of concatenation with user input. All right, next your book talks a little bit about methods and objects. And so just so that you understand, any data within Python is considered an object. And so a number can be an object, a string might be an object, so forth. So anything, any programming thing could be considered an object in Python. Now you can reference the object or obtain information about an object that you declare using the ID or type functions. So when you declare an object such as a variable, what it does is it reserves a spot in memory for that particular object or for that particular variable, and it gives it a number within memory so that it can refer to that number and be used time after time. So here are a couple of examples of using ID and type. So what ID does is it returns the numeric identifier of an object. So we have declare an object variable here called myString. We say the value of it is hello in quotation marks. And then we print out to the console the ID of myString is, and then we type out the ID, return the ID of my string. And whenever we run it, we'll notice that it gives us a number here. So the ID number of my string is this big long number here. Now we can try running again and you'll find something interesting that happens. Now this ID number is different, and just notice that every time you run, it reserves a different place in memory for this ID. Now we also have a float that we declare called y, and we say that it's equal to part of the allocation for the number for pi. And then here we print out the data type of y is, and then we use the type function and to pass that to the value of y to return the data type that is. And we notice that whenever we run that it says the data type of y is, it is of type float. So we can use these as debugging functions, the ID and the type, in order to understand how the Python interpreter is looking at our variables that we create. All right, there are a lot of other methods that we can use in Python to manipulate text. The first type, very simply, is the upper and the lower functions. And so here we declare a string variable called welcome, and then we say print out to the console s, which refers to our variable here, s.upper. So in other words, it's saying take the value of s and then convert it to uppercase. And we do the same thing for lowercase. Let's see what happens when we run this. So we notice whenever we run this that first we told it to convert the welcome string into uppercase, and it did it right here. Then we tell it to go in to convert it into lowercase, and again it did it right here. Okay. So the upper and lower methods are helpful to format data into a more uniform format. We also have what's called the strip function, and it's really helpful for us to trim extra text from strings, and it's really helpful whenever you're trying to get user input. Now, so say for example you're wanting to run, you're wanting to gather the first name of a user, and so it's going to prompt them for that, and then you want to print it out to the console. And what X is going to do is we're going to apply X to the function strip, and then we'll have the then we'll end with the period. And so say for example we're the end user and we type in our first name. My name is Brian, and then I'm not paying attention, so I add all these extra spaces. So what the strip function is going to do is it's going to remove those extra spaces so that whenever it prints it out to the console, we'll only have Brian with a with the period. Okay, so easy enough. That's what the strump function is. We also have the format function. It's really powerful because it's able to do some conversions with floating point numbers. A lot of times you might be dealing with dollars and cents, or you might want to convert something um, to percentages. You know, there's always a need for that within programming. So, say for example, you've got you do some sort of calculation and realize that we have an answer that's 57 and 45 $57.45, but we have a bunch of extra floating point numbers and we need to just kind of chop them off. We can use the this particular function in order to format our text. And so we notice that we have a function, the format function, that is used to format floating point numbers, and the format that it uses is width.precisionf, and where width is the number of numbers on the left of the decimal, and where precision is the numbers on the right side of the symbol coupled with the letter F. And so when we run this, we notice that 57.452346, when we say limit it to width 10, and on the right side, we only want two numbers on the very end. So we notice that 57.452346 gets concatenated to, or gets trimmed to 57.45, and then 57.4, when we apply it to 10.2f formatting, it expands it to 57.40 because we're expecting two integers at the very end. So we can actually change it to 3 and run it. And you'll see that by doing that, what has actually happened here is that it's given us 3 decimal points here. So 57.4 has become 57.400. So this is the number of left side numbers, this is the number of right side numbers, and just remember that whenever you're doing with floating point, you use the F. Okay. Now you can also use the percentage conversion code to format a number as a percentage, and to do that, it's a very similar thing. We have a decimal here, and we say using 10.2 formatting, you can convert that to percentage. You notice that if we have 0.53457, if we want to convert it to percentage, then it converts it to 53.46%. So very handy, very easy, but it allows us to format numeric input for the end user. Now, the last thing that this particular chapter covers is drawing in Turtle. And once again, we have used Turtle in the past a little bit, we've gotten our feet wet with it. But just as a point of reminder, we have several methods that your book shows that are helpful. And so we, just as a review, we note that turtle.pinDown function puts the pin down and draws while moving. Turtle.pinUp pulls the pin up off the paper so we don't have any drawing when moving. And then we can also change the width of the pen using the turtle.pinSize with a width argument to set the line thickness. Now, there are a ton of turtle motion methods that are available, and once again, I would encourage you need to look at table 3.6 in your book in order to kind of understand them. There's one thing that's kind of interesting is the circle method. There's a method called circle, which takes 3 arguments. We have first the radius, which is required, and then we have the extent and the step arguments, which are both optional. And what step determines is the number of sides in a polygon. So if we have 3 steps, then we know that we'll have a triangle. If we have 4 steps, we'll have a rectangle. If we don't have any step that's specified at all, then we will get a circle. So let's run this particular program and see what happens here. So what's happened here as we said, turtle. We've imported turtle first, and then we said set the pin size to 3. Now we could be different. We could say set it to 8, and let's run it and see what happens. Okay, you notice that whenever we change the pin size, it's much thicker than it was before. And then we say turtle.pin up, so the pin is no longer writing. And then it says turtle.goto minus 200 minus 50, and that is based on where the center is. It says go to the left 200. I guess it's probably, here's probably the center. It says go to the left 200 or go back 200 and go 50 to the minus. And when we do that, it sets the pin cursor here. And then the next line says turtle.pin down, which puts the pin on the paper. And then this last line of code here says turtle.circle 40, which refers to the radius, and then steps equals 3 to draw a triangle. So whenever we run it, this is what it looks like. Now we could change the steps to, let's try 4 and see what happens. When we do that, we notice that it creates a diamond with 4 sides. And similarly, if we wanted to do 7, we do the same thing. And so now we're getting a septagon at this point. And so there are a lot of really cool things that you can do with Turtle. So what I would recommend that you do is that you look at, and in your booklet, you have for this particular in your book for program listing 3.5 is called simpleshapes.py. I would highly recommend that you walk through all of this particular program in your book, 3.5 simpleshapes.py, to practice a little bit with turtle drawing, and that will allow you to get your feet wet a little bit in some graphic design. The last thing that we want to talk about today is a little more with Turtle, in that there are a lot of methods that you can use for changing the color fill of a shape. You can also use it to clear the screen and so forth. And you know what I want you to do is I want you to study all the methods that you find in table 3.7. They're all really self-explanatory, but it's just really helpful. You do need to do that. Just to be able to understand how to write and draw with Turtle. And so we have a piece of code here that we want to kind of analyze, and the first one is set the pin size to 3, and then we say turtle.pin up and go to minus 200 pixels and minus 50 pixels from the current from the middle page, and then we say turtle.pin down. And then we use the begin underscore fill function. What that does is that tells us that anything that gets drawn after this, we want to fill it with color. And we notice that the color, by default, it's going to be black, but if we specify a color, we can put that color as an argument for total.color or a parameter, and whatever color that is inside there, it will do that particular color. And then it says draw turtle.circle with radius 40, steps equals 3, and again we know that that's going to be a triangle. And then after that we specify turtle.end fill, and what this does is this tells the interpreter to stop filling anything at this point. So let's see what happens whenever we run this. So what we got here is we went start at the top or at the middle, and we went minus 20 or 250 pixels, put the pin down when we filled it with the color red, and then we told it to stop filling also. Now obviously there are several different things that you can do to modify this. So say we want to do blue instead, and we wanted the pin size to be 6 or 7, and then say we want steps to be 6. Let's see what happens here. And here we get a blue hexagon. So a lot of power that you have just using these turtle commands. And so what I would like you to do, this is the beginning of listing 3.6, which is called colorshapes.py, and go through the entirety of that to get some more practice with using colors and shapes in Turtle. All right, this is everything that I have for you for this week. You do have a homework assignment which includes 5 questions from my programming lab, and then 2 programming problems that are in the book that you will utilize in order to do your homework. So if you have questions or any problems, please make certain that you contact me, because I am more than happy to help you out. Have a great week. We'll talk to you later.